We try to focus on this really difficult discussion about space mining that is strictly related to what we've just heard in group one, so interplanetary missions. And so the main questions that we had to discuss about are what are the capabilities or technologies that we should develop in order to have space mining, and how can they help space mining activities? And the main questions was also about can they be just of secondary support to space mining activities, or we could use small satellites also for primary objectives. So our discussions stemmed from the following principles. The first one is why. So the main problem is that space mining is more of a commercial idea. So we want to make money out of something. But the first important thing is that why do we want to do space mining? And in order to answer these questions, we need to plan missions that might also lead to a no-go. So we might also find out that space mining is not worth it. But at least trying to give this answer through a set of incremental missions, we'll have found something, we'll have developed technology that can be used for other missions. So that's the concept of spin-off technology. So the important thing is that try to answer that questions and do everything you can, but keep in mind that it's more important to develop technologies that are useful for other fields other than only focusing on one target and maybe not being able to get there. So the important thing about space mining just is we have to select the target. So there's some information we already have. We need astronomical surveys. We already have catalogs, and orbital dynamics study can actually help us locate the best asteroid to reach. And we would just then cut it down to a close subset, to a small subset of easiest targets to reach. And the target will also be selected not only according to dynamics, but also according to the raw materials we need. And asteroids are very rich in composition, so we'll have to scavenge a little bit for finding useful resources. We need to locate where do we need to use the materials, and we should, of course, consider intermediate steps like lunar demonstration sites where we can implement the technology. So this is the priorities, the technology that we need to develop. And the idea was to have a multi-mission architecture in which we could try to develop and study one of these subsystems at a time, and then try to integrate them together, starting from the lessons learned, in order to converge towards a bigger and richer mission. So the most important part is sensors. So we have a lot of sensors, but we have to go towards the miniaturization of sensors if we want to put them as small satellites. Then the communication is really important. So by a simple study of the link budget, we can play with it and know what we have to build in order to communicate from the asteroid to Earth or to the moon, and that's not straightforward. And in that field, we have thought about inflatable antennas and also laser communication, as I heard in group one, the discussion. Power is really important, but there would be a second priority also because there is a lot of research ongoing in other fields. And propulsion will be a very important point, and autonomous operation, and I'm going to tell something more about it. So the important thing is that we need to establish a data rate to transmit the data from the asteroid to Earth, and there's a huge amount of data to transmit. But if we have a common and data landing system, and if we implement algorithm on the CubeSats, on the small satellites that are able to distinguish the important and useful information from the known important, then we can select all the important information and send it back to Earth, so that we don't need a very big data rate to transmit. And the system budget model is actually the point that summarizes all the points above. And to end, so we just thought about the space mining activities that we might want to do, So there's of course 3D printing of regolith using, so try to make pieces out of regolith. We should develop new fabrication concepts. So we have come to the conclusion that we cannot export the production methods that we have on Earth to space, because actually this technology is not transferable. We need to know how to capture the material, and so do we need to grind down the asteroid to powder and then collect the powder? That's not straightforward, so we need to study systems to be able to collect. And then how do we transfer the raw material or the finite product to where we need it? So these are questions that arose and that we're not able to answer yet. But if we follow an incremental scenario in which we try to go on step by step, we'll eventually end with some benefits, even if we won't be able to do space mining in the end, but the benefit will be assured. Thank you.